Okay, hi. I just want to go through this quiz with you so that you have a clear idea on how to really think about the questions and get the right answers. Before I start this, I'm just going to mention that the numbers in this quiz might be different than the numbers on your quiz because this is a different version, possibly. Okay, so just keep that in mind. Question number 1 asks you about a ball which is fouled and hit straight up with some initial velocity. So that's the ball. And of course, the idea is it goes straight up and it comes back down. Okay. And you're told that the ball is actually in the air for 7.2 seconds before it comes back to its starting point. And then you're told that an announcer claims that the ball must have been doing 30 meters per second when it was hit. And you have to evaluate that. So your mission is to figure out if that's right. So I'm going to show this to you a couple ways, actually 3 ways. Here's the first easiest way. You should know that the time that an object spends in the air can be divided into 2 parts. There's the time up and the time down. And those times are equal. So if the time in the air is 7.2 seconds, then the time spent going up is going to be half as much. And so that would be 7.2 divided by 2. That's 3.6 seconds. Now, a fast way to answer this question is to say that if something spends 3.6 seconds running out of speed, how fast was it going if it took 3.6 seconds to go from here to the very top of its, the top of its position. Okay, so say right here. If this is the initial, in other words, this is your final up here. If it took 3.6 seconds to run out of speed, how fast was it going? Well, you have to remember that gravity takes away about 10 meters per second of speed per second. So you could estimate this, and you could say, well, it's probably starting off with 36 meters per second of velocity because gravity is going to take away 10 of those units per second, and this is happening for 3.6 seconds. So you could kind of reason it that way. And so you could kind of figure that your velocity, your change in velocity is going to be equal to the acceleration of gravity times the time spent going up. So we're talking about 9.8 times 3.6. And that's like it's actually 35.3 or something like that. But that's the answer, okay? And so you could almost do that in your head, right? So you can try this. You can say if something spends let's say that something spends 8 seconds going up, right? So it's in the air for 16 seconds. If it spends 8 seconds going up, it must start with a speed of 80 meters per second because gravity is going to take away 10 per second. All right. Now, if you want to be more formal about it this way, another way to set up this exact same thing is to use the formula VF equals VI plus AT. Sometimes people like to really use a formula that they can count on. And so let's look at what we call I and F. What's initial, what's final? My initial is at ground level, and I'm going to say that my final is at the highest point. So my initial velocity is what I want to get. My final velocity is 0. And since I made my initial velocity positive, I need to write my acceleration as negative 9.8. And the time I'm spending going up is 3.6 seconds. Now, if you follow the logic of this, you're going to get the exact same answer that we got before, right? Because you bring VI over. That makes it negative, but then you have a negative here. And you still end up getting the exact same thing. So officially, this formula can be used. In fact, that's kind of what we were using over here. But this is writing it out in all the detail. Now, I'm going to show you one more way of doing it. Except now we're going to make the initial point down here. And we're going to make the final point when it comes back to that level. And so the nice thing about picking this setup is that you can say overall the object comes back to where it started. That's a displacement of 0. So now I'm going to use this formula. Displacement is equal to v initial times time plus 1/2 at squared. I'm going to use delta y for displacement because it's in the vertical direction, but you can use delta x or even d, I suppose, if you want to. So my delta y is 0, and that's going to be equal to v initial, which I don't know. And now I have to think about what t I should use. And because it's the time up and down, now I would use 7.2 seconds. So that becomes 7.2. Then I have plus 1/2 a. This is actually plus 1/2 times negative 9.8. I have to make it negative because I've chosen up to be positive, down to be negative. And then I'm running out of space here, but I'm going to multiply that by 7.2 squared. Okay. So if you do the math on this, I'm going to take this term and bring it over. That's going to be negative 7.2 times v initial is equal to, this will give me a negative on this side. It's going to be, I got to work that out. It's going to be 0.5 times 9.8 times 7.2 squared. That gives me negative 254. And then my v initial is going to be obtained by dividing both sides by 7.2. And voila, that gives me the same answer that I got the other ways. Okay, so this is a different way. This is a kind of a second, I guess maybe a third way of solving it. It's really a second way because these two are kind of the same that we did first, and that one's different. But a main thing I want to say is just don't grab numbers and stick them into an equation, and because a lot of people did that. And you can't just take the 7.2 and stick it into this equation. That will be wrong. And you can't just take the 30 and stick it into any of these equations. Some people actually did choose to use 30 and show that the time wasn't 7.2 seconds. That's okay. This announcer, by the way, would say that the ball should be in the air for a total of 6 seconds. And I will let you think about that. Okay? So according to the announcer, it should only be in the air 6 seconds, not 7.2. And that is an indication that the announcer was wrong. Okay, let's go to number 2. This 2 and 3 we'll go a little bit faster with. In number 2, it doesn't hurt to draw a picture. Again, you've got a ball going straight up. The ball goes up, comes back down. Okay. You are told that the initial speed is 25 meters per second, or whatever. And so immediately you should start thinking about, well, how long is the ball going to be, how long is it going to spend going up? So could you answer that? If you launch at 25 meters per second, how long does it take to run out of speed? And I hope you can say, yeah, it's going to be about 2.5 seconds. So now you look at your chart over here, and the chart has times in it which go beyond 2.5 seconds, a little bit. But I'm going to kind of anticipate that these times are not going to be long enough for the ball to come back to me. Okay, so what do they want me to find in the table? In the table they want me to find the height of the ball. In other words, how far above me is it? And so this is going to require us to use, again, the formula that looks like this. Okay. And so delta y is kind of like our height in this case. So we could probably say h is equal to that. That's the displacement from the starting point. Okay, so and then they give us information here. So my height is equal to initial velocity of 25 times t plus 1/2. And here's where a lot of people went wrong. Negative 9.8 times t squared. So, people, you are committing to the positive direction being up in this problem. Therefore, you wrote plus 25. That means that the acceleration of gravity needs to be made negative. Okay? And if you can follow through with that, you're good to go. So let's do the first point together. We would have it 1 second, plug in 1, plug in 1. You end up with what? 25 minus 4.9, and that's equal to 20.1 meters. So we could round that off to 20 meters. Okay. So in other words, if there was no acceleration, the ball would actually go 25 meters up. But because it's accelerating in the opposite direction, you have to take something away. And what you take away is this part. And that's why it's got to be negative. Now, when you do the next set of numbers, you're going to end up with this. The next set is going to be 25 times 2, so it's going to be 50 positive. But then you have to subtract 1/2 times 9.8 times 2 squared. And that's going to be actually 19.6. And so now you're going to get something which is about 30. Okay? I guess it's 30.4. So this is 20.1. When you go to 3 seconds, you're going to end up with 25 times 3, that's 75 positive. But then you subtract off, it's like 44.1 or something like that. It's 1/2 times 9.8 times 9. So it's 4.8 times 9. Or 4.9 times 9. So it's 44.1. And when you subtract, you get 75 minus 44.1. That's 30.9. So those are the answers. And honestly, what you're looking at here is in that going from 0 to 1 second, the ball covers a lot of distance. It goes way up to here. Then from 1 to 2 seconds, it goes a little bit further. And then from 2 to 3, it doesn't change much because it's in the process of turning around. So kind of the 3 points, this is at 1 second, this is at 2 seconds, and this is at 3 seconds. And we're not going any longer. So that's kind of only the 3 places that I wanted you to find. Hopefully you would know that if we went all the way to 5 seconds, right, the ball actually should be back to you, or close to it, right, pretty close to it. And you can try that out, because we know it should take 2.5 seconds to go up, 2.5 seconds to come down. Okay, so that's how you do that. So common mistakes are not using a negative here for 9.8. Don't make that mistake anymore if you have an up and down problem like this. All right, the last question is a reasoning question. And it says that Dave drops a book from the tabletop. It takes T seconds to strike the floor. Dave claims that if the book falls twice the amount of time, then it will fall twice as far. Okay? And you want to evaluate that claim. So let's do it with some numbers here. You'll see how, how this is not true, right? First of all, our formula is that the distance again, let me write it this way. Delta y is equal to v initial t plus 1/2 at squared. Now, Dave's doing this book drop from rest. Okay? It says that somewhere, or you assume it. So that's just 0. So basically we're down to a situation where the book is falling a distance equal to 1/2 times g times t squared. Okay? Now just do a quick check here, right? Take the time, make it 0, 1, 2, 3, 4. This is a good exercise. How far does this thing go? So let's just use 10 for g. So that means that this is equal to 5t squared. So you end up with 5 times 0 squared is 0. 5 times 1 squared, 5. 5 times 2 squared.